Hello ladies and gentlemen, this is Miss Koken. We're in section 3-6, lines in the coordinate plane. And in this section we're going to be putting together some of the information from the last two sections along with some of our previous knowledge from Algebra 1. Let's read the objectives together. Graph lines and write their equations in slope-intercept and point-slope form, and classify lines as parallel, intersecting, or coinciding. For vocabulary, we have point-slope form and slope-intercept form. Let's take a look at what each one of those looks like. Let's say we have a line that goes through a point -5, 19 and has a slope of -3 and has a y-intercept of 4. Remember that a y-intercept is where the line hits the y-axis, and when a point is directly on the y-axis, we know the x-coordinate of that point is 0. To write the point-slope form, we're going to use the point coordinates and the slope. So that means it's going to be y minus our y-coordinate 19 equals m, our slope, x minus -5, so that's going to look like an x plus 5. And that's it for point-slope form. For slope-intercept form, it's going to show the slope and the y-intercept. So that's going to look like y equals mx plus b. And in our case, with our particular line, we insert the slope, we insert the y-intercept, and that is slope-intercept form. So we're going to be using both of these in the lesson. We've got 4 warm-up questions, so I'm going to ask you to pause the video to work on those, and then of course turn the video back on when you are ready to check your answers to those 4 questions. I'll see you back in a minute. In questions 1 and 2, we just needed to plug in the values that were given to us in the problem and then solve for b. And in questions 3 and 4, we needed to solve each equation for y. That's another way of saying manipulate and rearrange so that it says y equals. When you're solving for a particular variable, that means on the left-hand side you're going to have that variable, then an equals sign. Okay, if you have any questions about these, of course, bring them to class. And we move on. It says in our notes, the equation of a line can be written in different forms. We know this, we were just looking at some of the forms. And the equation of a vertical line cannot be written either the point-slope form or in the slope-intercept form. And let's just think about that for 1 second. When we have a vertical line that goes through any particular x value, like negative or like +2, for example, then the equation of the line is always going to be written in the form x equals and that constant. And another way that you can look at this is in this line, the only value of x that ever appears in any of the coordinate pairs is 2. So when we think of all of the different points that are on this line, and we can list some of them, we can see that 2, the x value, the x coordinate, is always, always, always 2. The y coordinates change. And the number of y coordinates is going to be infinite because every single y value is on that line, but always with the x coordinate of 2. All right, let's take a look at the box forms of the equation of a line. We talked about the point-slope form just a second ago, and you can see that the form of that is y minus y1 is equal to m times x minus x1. And I want you to think about this just a minute. Imagine if we divided both sides by x minus x1. Writing it that way reminds us of the formula for slope. So it's another way for us to look at this. And it always shows us the point and the slope that are in that line. The form always has a minus sign. Y minus y1 equals m times x minus x1. So be careful with your positive and negative signs as you go through. The slope-intercept form is the one that we're familiar with from Algebra 1. Y equals mx plus b, where m is the slope and b is the y-intercept, which once again is where the line intersects with the y-axis. Then we have the equation of a vertical line, again always in the form x equals a constant. And the equation of a horizontal line is always going to be in the form y equals a constant. We can see the reminder up at the top that says a line with a y-intercept of b contains the point 0, b and a line with the x-intercept of A contains the point A comma 0. So we need to just keep that in mind when we're trying to find the slopes and or when we're trying to write the equations of a line. Example number 1, we're asked to write equations of lines in a specific form. So in question A, we have a line with slope 6 that goes through point 3 comma negative 4, and we need to write it in point slope form. We have everything that we need because we have the slope, we have the x-coordinate, and we have the y-coordinate, and we can write down our equation. Y minus y1, which is negative 4, equals m 6 times x minus x1, which is 3. And the only thing that we can do, of course, here is to simplify the minus minus in a row, and we've got our equation in point slope form. The next question wants us to write the line in slope-intercept form, and we're given 2 points that are on the line. So the first thing that we need to do is find the slope. You can see in the name slope and intercept, we need to find the slope first. As always, we're going to start with our slope formula. So we write that down first, and then we're going to do proper substitution. So 2 minus 0 is going to give us 2, and 1 minus negative 1 is going to give us 2. So our slope is equal to 1. We're being asked to write the equation of the line in slope-intercept form, but the easiest way to get there is through point-slope form. So let's plug in the slope and one of our points. We can see that this is going to end up being y is equal to 1 times x, using the distributive property, is just x, and then we have a minus minus, so we know that that goes to x plus 1, and then we have 1 times positive 1, so that gives us x plus 1. We are in slope-intercept form, and we're done with this question. In question C, we're given an x-intercept of 3 and a y-intercept of negative 5, and what that translates into is we have 2 points. The x-intercept is going to be at 3 comma 0, and the y-intercept is going to be at 0 comma negative 5. And we want to write these in point-slope form. So, of course, point-slope form, we need the slope. We're going to find the slope first. Once again, point-slope form is y minus y1 is equal to m times x minus x1. So we're just going to plug in one of the points and the slope. Let's plug in 3 comma 0. So y minus 0 is equal to 5/3 times x minus 3, and we are done. And even if we don't see the y minus 0, if we see a y alone, we know, of course, that means that the y-coordinate of the point that we're using to create the point-slope form is, in fact, 0. Let's take a look at example 2 now. On example 2, we have 4 different lines that we're going to graph, and we're going to start out by looking to see what information is being given to us for each one of these lines. On A, we can see that we have it in slope-intercept form. That means we've been given the slope of 1/2, and that means we have a rise of 1 for a run of 2. We also have the y-intercept, and that gives us the point where it hits the y-axis, and we know that when it hits the y-axis, the x-coordinate is always 0. So let's start by graphing the y-intercept at 0 comma 1, and then we're going to use the slope. So we're going to have a rise of 1 and a run of 2 to get our next point. And it's going to continue that pattern, so we can graph a few extra points and then we'll be able to draw the line between them. We're going to label the line. Since we're going to have 4 lines on here, we want to label them. And color coding them, of course, makes it a lot easier to see also. So we have graphed the line for question A. Let's look at question B. We see that B is given to us in point-slope form. And point-slope form looks like y minus y1 is equal to m times x minus x1. So we can see that our slope is m is equal to -2, and now we need to figure out what x1 and y1 are. to be able to graph one point on the line. The point slope form has a minus sign built into it, so we have to respect that. And what we're going to, the way we can set it up is take that x plus 4 and set that equal to x minus x1 from the point slope form. If we subtract x from both sides, we end up with 4 is equal to negative x1. And if we multiply or divide both sides by negative 1, we'll see that we have negative 4 is equal to x1. If we do the same thing for y minus 3 is equal to y minus y1. And we can see if we subtract out the y's, negative 3 is equal to negative y1, or y1 is equal to positive 3. So what this means is we've got our point. Our point is negative 4, comma 3. Let's graph that now. Negative 4, comma 3. And we're going to have a slope that is a negative 2, which we can look at as negative 2 over 1. So it's going to go down 2 and over 1 for us to get the next point. Now let's draw the line between those 2 points. Now we need to label this line, and that was from B, which was y minus 3 is equal to negative 2, x plus 4. Okay, let's move on to question 3. It says y is equal to negative 3. And we remember from Mr. Slope Guy that that's going to give us a horizontal line. The horizontal line is going to be at y is equal to negative 3, so we go down to y is equal to negative 3, and we graph our line. And of course we need to label it, so this was question C, y equals negative 3. And this line has a slope of 0. Now it's time to look at question D, and question D says the equation that we need to graph is x is equal to 4. We remember that this indicates a vertical line. So we're going to go over to positive 4, and we are going to draw our vertical line. When we label it, remember it's going to always be in the form x equals, that's what was given to us, and in this case, the slope is undefined. We have graphed all 4 lines, and now we're ready to move on. A system of two linear equations and 2 variables represents 2 lines. We know that the lines can be parallel, or can intersect, or they can coincide, which means that they are the same line. Parallel lines are indicated by having the same slope, but a different y-intercept. We have to be clear about that, because if they have the same slope and the same y-intercept, then they're actually the same line. They're not 2 different lines. And when we have intersecting lines, they're going to have different slopes. They can have the same y-intercept, and that may be their point of intersection, but they will definitely have different slopes. So let's take a look at example 3, classifying pairs of lines. We're going to use the information we just learned about. The instructions say determine whether the lines are parallel, intersect, or coincide. So we need to check out the slopes from both of these. And when we see this first line, y equals 3x plus 7, we have a slope of 3. The second line has a slope of negative 3. Now, those are definitely not parallel, nor can they be coinciding, because they would have to have the same slope in either one of those cases. We might want to check to see if they are perpendicular. We already know that they are intersecting because they're not parallel and they're not the same line. And if you remember, lines that are perpendicular to one another have negative reciprocal slopes, or the other way that we can look at it is if we multiply the 2 slopes together, we end up with a result of negative 1. In this case, we end up with a result of negative 9 when we multiply the 2 slopes together. That is definitely not equal to negative 1, so they are intersecting but not perpendicular. That brings us to question B with a new pair of lines. The first one, y equals negative 1/3 x plus 5, we can see that we have a slope of negative 1/3. The other line is not so convenient to us because it isn't solved y equals. So we're going to need to rearrange it. We really just need to divide both sides by 6 so that we can have it in slope-intercept form. When we divide both sides by 6, we see that, in fact, we do have the same slope on both of these lines, and we have a different y-intercept on both of these lines. So we can say that these lines are parallel. We've had one intersecting, one parallel. Chances are the next one is going to be coincident, but either way, we need to start out by finding the slope, and the easiest way for us to do that is to put them both in a form that is the same, either slope-intercept or point-slope. Let's put them both in slope-intercept form. Once we have them both in the same form, in that slope-intercept form, we can see that they have the same slope and the same y-intercept. So these lines are in fact coincident. Now, you've got a couple to try out yourself, so I'm going to ask you to pause the video, work on questions A and B of the Now You Try, and then turn your video back on when you're ready to check your work. Hopefully you didn't have any difficulty with those, and you remember that horizontal lines and vertical lines are perpendicular to one another. If you have any questions about these, bring them to class and we'll discuss them. Okay, we've got a real world problem here, and Erica's trying to decide between two car rental plans. For how many miles will the plans cost the same? So we need to set up a system of linear equations here because we have a couple of variables for plan A and a couple of variables for plan B. Specifically, we have the initial fee and we have the mileage fee. Presumably, Erica is concerned about the total cost that she's going to end up paying for both the initial fee and the per mile fee. The initial fee is going to be our y-intercept on both of these, and the mileage fee, because we need to multiply by the number of miles, that's going to be the rate of change or slope. Together, when we add those two variables, we're going to end up with the total cost. So let's define our variables as x is the number of miles that we're going to need to throw into the equation to be able to get y, the total cost. For plan A, y, and I'm going to call it y sub A, is equal to the initial cost of $100 plus the per mile cost of 35 cents times the number of miles x. For plan B, we're going to set it up as the initial cost 85 plus the per mile cost of 50 cents, and that multiplied by x. The question asks for how many miles will the plans cost the same, and because they're both in slope-intercept form, the easiest thing for us to do is to set them equal to each other. So we're going to say y sub A is equal to y sub B, and then we're going to substitute in these expressions. Now we can combine like terms and solve the equation for x. Once we solve and we remember that x stands for the number of miles, we can say that for 100 miles, both plans A and plan B will have the same total cost. In order for us to find that total cost, we need to plug x back into one of our equations and find the y. Then we can write our final answer in a sentence. There's a Now You Try for you to practice this idea of setting up a system of equations using a real-world example. So I'm going to have you pause the video and try this one out. I know that sometimes word problems are a little bit awkward, but just follow the model of the one that we just did together, and then turn the video back on when you're ready to check your final answers. Okay, hopefully you were able to follow the model of the one that we did together to be able to come up with to the conclusion that after 4 months, or at 4 months, the two plans, plan A and plan B, would cost exactly the same amount, $280. And that is the end of the lesson, so we're ready for our practice problems. As always, any questions, bring them to class next time we meet, and I'll see you then.